Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at strategies for implementing tasks in the math classroom, and this is part 2 of webinar. If you missed part 1, we'll show you at the end where you can download that for free. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, I'm excited to be joined by our 2 panelists, Dan Alaria and Jeremy Zelkowski. Dan is a T-Cube National Instructor and Professor of Mathematics Education at West Chester University of Pennsylvania. And Dan's taught middle and high school math, as well as been a supervisor of mathematics for several school districts in New Jersey. Currently, he uses TI technology with pre-service and in-service teachers as part of pedagogy classes at both the undergraduate and graduate levels. Dan, thanks so much for joining us tonight.
Thanks, glad to be here.
And Jeremy taught high school and college math from 1998 all the way up to 2008, and then joined the University of Alabama in 2008 as he completed his doctorate in mathematics education. He is currently an associate professor and the program coordinator for the secondary math teacher education at the University of Alabama in Tuscaloosa. He's been a T-Cube National Instructor since 2014, and that includes offering workshops and doing conference presentations on TI-Nspire throughout Alabama. Jeremy, thanks so much for joining us tonight.
Good evening. Great to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send Dan or Jeremy any questions that you may have using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance as well as a link for the documents at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and choose Audio Broadcast. At this point, Jeremy, it is all yours. Feel free to share your screen.
All right. So good evening. Tonight we are going to focus on part 2, and we're going to give a little quick reminder. We're going to focus on implementing tasks that promote reasoning and problem solving, as well as use and connect mathematical representations. So our work this evening, we continue from part 1 a few weeks ago. This work is grounded in the mathematics teaching practices from the National Council of Teachers of Mathematics, their publication Principles to Actions from 2014. These research-based practices, when part of the mathematics classroom, are known to improve student learning outcomes. While we're focusing on 2 of these practices tonight, many of these practices have been a focus point of professional development projects throughout the last 5 years since this publication in 2014. And again, we're going to be thinking about the implementing tasks that promote reasoning and problem solving and using and connecting mathematical representations. But these 8 practices intertwine during the lesson, during lessons of instruction. So we will find some components of each of them throughout the webinar tonight, and even with some of the tasks that we work on and the conversations that we have. So in the chat box, we'd like to kind of start with engaging those who are on our webinar tonight. Can you give which of these other, the 6 of the other teaching practices do you feel like would integrate easily with the 2 that we are going to focus with tonight? And I see a number of different responses coming in. Dan, anything you want to share from the text boxes? Are the chats that we're seeing?
It's looking like 4 and 5. Those two practices are what most people are focusing on. Thanks to everybody who is responding to that question that I threw out there just before Jeremy asked his about if you're new this time or if you joined us last time. It's a lot of posing purposeful questions and facilitating discourse.
All right. So as you can see here, there's not a specific one that necessarily integrates perfectly with those. It really depends on the type of lesson, and we're going to kind of see some of those things tonight with what we focus on here with the part 2 of our webinar. So our agenda tonight really is going to focus on two questions that sort of follow from what we did with part 1. So while we're focusing on a couple of these teaching practices, we see from a number of our attendees on here tonight that we can see that other teaching practices easily relate to those two practices we are focusing on tonight. So while part 1 of our webinar spotlighted the research on which the assignments, on whether assignments in our math classrooms are measuring up, and Dan's going to give us a quick refresher on that, from a national sample of assignments that math teachers have given students. We also, in that part 1, we reviewed 4 characteristics of tasks that quote measure up to tasks of high quality. And we also focused on the importance of using and connecting the representations within those tasks. So tonight we extend that, and we are looking at strategies to help ensure tasks of high quality, and we look at some means in which we can adjust lesson tasks and try to make them measure up. So we're going to have some strategies tonight, and we're going to cover a couple. We're also going to look for some of the norms and give some suggestions for how we can create classroom norms for students, but then also how teachers can create that environment in which these tasks can be implemented, keeping an eye on these two practices for tonight. I do want to remind everyone at the end of the webinar tonight, there will be a link to complete a survey, and there'll be a promotional giveaway for some of the folks that actually complete that survey.
So last time, we introduced this research report, which took a look at tasks that were given to middle school students. And the basic result of this was that the majority of tasks reviewed in the study were procedural or recall tasks. So the research laid out some characteristics to talk about what are ways that we can create high-quality tasks, or what are the characteristics of high-quality tasks that promote reasoning and problem-solving. And our awesome host, Mr. Houston, just posted a link, the link that's on that screen, into the chat window, in case you want to click on that directly if you haven't taken a look at this. It's got some good examples in it. So we're going to just do a quick review on the next slide about what characteristics are make tasks meet these criteria of promoting reasoning and problem solving. So the first one was promoting cognitive challenge, and there's lots of different ways to evaluate that. There's the depth of knowledge framework out there. There's the task level framework out there. As long as we're using one to talk about making these tasks be above that procedural or that recall level. The other criteria was we want tasks to balance procedural skills and fluency, which is something that is kind of a definition of mathematical rigor from the Common Core standards, just that the idea of we need to have conceptual understanding, procedural skills and fluency, and application all together. The task also has to provide opportunities to communicate mathematical understanding, which I think a lot of people who replied to us about what other teaching practices come into play, they were talking about questioning and the facilitating meaningful discourse. So we understand that that sort of conversation is important. The question, the criteria states, though, that we're looking for, are we requiring students to communicate their understanding using the language of math? Are they writing short phrases or sentences? Are they doing paragraphs? And is there time for informal or formal discussion? And then finally, when we talk about choice, there's a couple different ways that students can be offered choice. It could be in the content, it could be in the product that they produce, it could be the process or the strategy that they use to solve the problem, or it could be a mathematical tool, maybe using a calculator versus not using a calculator or some geometry tool, and making assignments relevant by focusing on interesting topics, or may just arouse some sort of curiosity. Doesn't necessarily have to be that real world idea, but at least giving students the opportunity to make connections with whatever they're interested in or their values are. And so as we go into what we're going to talk about tonight with tasks and how do we make sure our tasks meet these criteria, we want to be clear about what do we mean by tasks, and the research study defines it as we've written out here. There are assignments that are completed during teacher-led practice or assignments completed during teacher-led practice or substitute teachers were not counted, but it's basically what students complete independently, either in or out of school, or with a group of peers. And so the study describes how this is a powerful way to see the day-to-day experiences of students, and they give those 5 descriptions about how this lens of looking at what students are doing either independently or in groups describes the type of mathematics that students engage with, how they interact with the curriculum, how they reflect teachers' beliefs and expectations, etc. And so we've come up with a couple different options for ways that tasks can be revised or adapted to measure up, to promote reasoning and problem solving. And so the 4 that we described, and we're not going to touch on all of these tonight, but the first one is the idea of descaffolding. And so I think we're all familiar with the idea that a lot of textbook problems provide all the steps or give away the mathematics to students. And so this strategy is getting us to think about how can we, instead of recreating the wheel, take what may be in our curriculum materials and modify it to raise the cognitive demand. And we're going to look tonight at some TI activities that are on the website and see how we can do this for an 84 lesson and an Nspire lesson to descaffold some of it to improve the cognitive demand of tasks. Because if your students are already familiar with the technology, the activities may include a lot of step-by-step instruction so that the technology doesn't become a barrier. If that's the case, then your students may not need that information and all of those steps, so we want to talk about ways that you can remove some layers from the activity. The second strategy is compare and contrast, and we'll take what we mean by this is involving students in making a decision about which of several approaches or situation would be more efficient and useful. The third strategy is procedures to problems. We'll also tackle this one this evening. And this strategy takes that typical worksheet or that set of problems that may be in the textbook and refocuses it by doing some sort of analysis. So we get to raise the cognitive demand, but also end up doing a lot of the mathematics and that skill practice that we want, but building some of the conceptual points along the way too. And then the last one is reversibility. So the strategy opens up the task by giving students the opportunity to think about the question. So one of the things I typically ask my pre-service teachers is, rather than make up a linear equation, can you, to solve, can you create a linear equation that has a solution x equals 3? So that's what we mean by reversibility there. So those are the 4 strategies. We're just going to take a look at 2 of them tonight because we don't have a lot of time, and we do want to let people who are 84 users take a look at a task and what might be possible, and as well as those Nspire users out there. So there is a bit.ly at the bottom of the page, and Mike is going to put that into the chat window for everybody to be able to click on. And that link will take you to this activity, which is dilations with matrices on the 84 activities exchange. And the reason I picked this is because it does have a lot of those intermediate steps. The first page is actually, which I didn't include here, is a step-by-step of how to enter a matrix on the 84. So if your students are not familiar with that, then there's a great resource for that. But once they have that skill down, then we wanted to take a look at the majority of the task and see what we could do with it to de-scaffold, to get rid of some of these step-by-step questions. And so before we share our interpretation of one possibility of what you might do, I want to give people a chance to take a look at this, maybe take a look at it through the website on a separate screen, and think about what are some things you might remove from this problem in order to raise the cognitive demand, rather than have students kind of just follow step by step what you could do in order to kind of reach the conclusions that we want to.
So I'll jump in quickly, Dan, and just give a so our task that we're trying to present to participants tonight is, we're not looking to create something new or just a revision of what you see here or deletion of what you see here, some things that could be removed and maybe some rephrasing or combining of questions that would raise the cognitive demand. So we're going to give everyone a little bit of time here to kind of absorb what they're seeing on the PowerPoint right now, those 6 problems, those 6 questions, and think about it for a little while, and then add some comments in the chats, see some ideas that folks would be having.
Yeah, and one thing to think about is keeping the objective of this activity in mind, which is to explore the effect of the scale factor on the size relationship between the pre-image and image of a polygon. I think the example used in here is a triangle. But keeping in mind that we want students to understand the impact of using that scale factor between the pre-image and image. So that's what we're going for here. And initially, when these activities were written, we wanted to, like I said earlier, not have the technology stand in the way of getting through the activity, letting students be able to focus in on the mathematics. And there was an additional kind of application type problem after what I copied and pasted onto the screen. But I think between the two of us, we were thinking this is the major part of the activity that gets students to think about how does a dilation matrix impact the image and the pre-image.
Yeah, we're also thinking that sort of application question after these 2 pages you may not actually even get to during class, during the lesson, and so that's actually a rich problem that we may be looking for ways to actually get to spend a lot of time on that good question, where maybe we remove some of these procedural steps here, our students can actually get to that.
Yeah, and we should probably kind of say, well, you know, somebody else may look at this whole activity and see that last question, and then maybe use that as their launching point, which is another possibility too, right? That's a different way to raise the cognitive demand by having students start with an application problem before they understand how a particular concept works, right? So if anybody has some ideas out there about how they might descaffold this lesson.
So there's one comment. Could the student come up with coordinates for a new triangle?
Yep, so it looks like that's looks like it's touching on question 2, using this information, write a matrix multiplication problem to determine the coordinates of the image of the triangle. But that maybe that refers directly to that image where it's asked, like, what do you notice about that red and blue triangle that's up there?
Any other suggestions?
So I think now some people have given people enough time to think.
Okay.
Right, so some good suggestions. I think they're related to each other. Give the coordinates of both triangles and ask about the relationship, and so that could lead to, well, what is the dilation matrix? How would that work? If I were given my points in 2 matrices, would that mean I could then figure out what that other matrix is of how to get from one to another? So that's a possibility, and that would certainly help us understand how this matrix is impacting the size of our polygons between the pre-image and the image. So that's a possibility. One of the things that stuck out to me, I don't know if it jumped out at you, Jeremy, is questions 4, 5, and 6 are very repetitive, right?
Yep.
4 is about the image is larger, 5 is the image is smaller, and 6 is the image is equal. And that's where my thinking went. I don't know if anybody else out there was kind of paying attention to that piece, because it puts, right, it kind of like, it gives it step by step, right? I don't know if there's another way to describe that, right? It says, well, this one's going to be larger, this one's going to be smaller, this one's going to be equal. And my thinking was, well, can't I just have students play and almost rephrase it as, let's play around with this matrix that we're given or that we've just derived from the beginning of this problem and see what happens, right? How do you think it impacts the change? So let's jump to kind of our version of what we did to descaffold.
See if this was what some of you had
this problem. And I think it kind of focused in on the piece. So there were 2 questions in the beginning. We thought, yeah, let's just ask the first one because I like to ask what do you notice, what do you wonder questions in the classroom. And so I think still starting with that, what do you notice about the coordinates of the pre-image and image is a good place to start. I think it comes back to what some people said about asking about relationships between those coordinates. I decided to stick with giving that dilation matrix because this way I can have students play. So for problem 1 in the original activity, I said, let's get rid of question 2. Let's focus in on some noticing and wonderings. Let's talk about how a matrix can help work with that relationship. And then not deal with question 2. So we have more time to maybe focus in on the big idea of students understanding that relationship. So on the next slide, we took problem 2 and shrunk it down into just this one question. And it may not be the best worded question that I've ever come up with, but using that triangle, And I stuck with this triangle because the original page had students practice entering in this triangle, if I remember that original page correctly.
Yep.
But I figured instead of having those 4, 5, and 6 where we said larger, smaller, equal, let's just ask students to figure out how different values of K in that dilation matrix impact the size of the triangle. And so students will have to try different things. They'll have to graph it, take a look at it, and see what happens. And so
there's a little bit of a conjecture that they'll have to make about different values of K. It's very likely that they may skip over the values between 0 and 1 initially. And posing purposeful questions is a practice that would come into play here, so that they're making connections between the coordinated or the numeric representations and then also the visual representations that they see on the screen.
Yeah, great point. So they're still conjecturing. Like I said, it was kind of a neat part of the original one. But your point about posing purposeful questions, I think this question meets our criteria of raising the cognitive demand because we've removed some of the steps. Students aren't going to know that it might get larger or smaller. They haven't seen a lot of examples other than the first one. But we can use the original questions 4, 5, and 6 as our purposeful questions to ask students during the activity. They may even be kind of some scaffolding or differentiation we keep in our back pocket when we need it rather than kind of doing it up front. So we get the opportunity to kind of do some just-in-time differentiation rather than have it built in already by condensing all these steps together.
So I see a comment in the text chat. What do we do when our students would get one answer and they sort of think they've got the answer, and then they just repeat that and insist they're done? And like I was saying about potentially missing the dilation when it's between 0 and 1. So I think one of the things, I mean, every classroom is obviously going to be different, and we all know our individual students. I think probably at least the approach that I would take if I was working in one of my local classrooms with some of my teachers that I place my clinical students with, I would probably be looking more towards what are the sequencing of students doing within their groups, and I would probably be asking certain student groups to present what they've done rather than why don't you try values where K is less than 1 but positive. So rather than asking that, I think I would probably look for students that have actually done some of those explorations and let them present to the class. But I would try to sequence that in an order that maybe the first ones would be similar to what the rest of the class is sort of doing, so that it sort of builds the confidence in the classroom. But then also when there's a few students who have had the insight to check other values, I think that's where I would sequence those in. However, doesn't mean that teacher couldn't start jumping at the ones who do some of the more creative things and have them start the presentations. But that would be my first intuition to that question.
And you're addressing the whole implementation piece of this, which we have some slides on at the end after we talk about how do we get to these tasks. So yeah, the implementation piece is real important. So that's an example of an 84 activity we pulled from the activities exchange. Jeremy's going to show you a TI-Nspire one. And just, as he gets this set up, there's a link for you to access the activity directly as well from the website. But as you use these activities, keep in mind, how can you maybe raise the cognitive demand from what's been given because your kids can handle the technology, because they're familiar with it, or just because you want to challenge them and push them beyond what the way these activities are written initially. Good.
So this is a TI-Nspire file, and so if you use that bit.ly address, it'll take you to the activities exchange, to the home page of this particular lesson. And This particular lesson only has 3 pages in the actual TI-Nspire file. So there's the note page that you kind of see here at the top center of the PowerPoint slide. And then there's 2 pages after that that are virtually identical with the exception of one feature that's on the 3rd page that's not on the 2nd page. And the 2nd page really just gets students to try to create similar triangles, even though they're not laid out in a fashion that they kind of look like they're been easily transformed. They're kind of flipped and reoriented to where it's not obvious at the start. And as you can kind of see here with what's on for what it says move to page 1.2, which is where they're going to manipulate, and we'll see this on the next slide. But before we go to that, I want you to kind of think about as a group here, maybe how you can look at what you see here for all of the 5 problems that are under 1.2, and then also when you move to 1.3, it kind of jumps into the ratio that we get with similarity or with similar triangles. So really that's the 2 parts here, and like we did with the previous one, we're going to give you a little bit of time here to think about how you maybe collapse but not lose the mathematical focus of this particular lesson, and how we might increase the cognitive demand, remove some of the steps here, but also keep the mathematical focus of what this lesson is trying to accomplish. And then we'll look at some of the comments. And again, like the previous task, there is a rich question that is after question 7 here, which I'm actually going to share that with you, kind of see how that comes into play by descaffolding these 1 through 7 here. So we'll give you a little bit of time to think about that.
Yep, and the objectives from the activity, because we want to always keep those in mind when you mentioned, keep the mathematics in focus. One objective is proving 2 pairs of corresponding angles of 2 triangles are congruent. The 3rd pair of angles will also be congruent. And then students will recognize and apply the angle-angle similarity theorem. So that's what we're going for here. So as you're taking a look at this, right, think about, is there something that's repetitive? Is there something that's maybe stepped out? But you could change it in a way that still meets those goals of understanding and applying the angle-angle similarity theorem. I definitely think that's one of the more challenging pieces, don't you think, of keeping that objective in mind?
Yeah, it definitely is. I think when I looked at this and started thinking about it, my initial thoughts were, what questions on here do I think already have a cognitive demand for students, and how can I get them there without the step-by-step part? How can I still have them engaged in that? So that was what I was thinking when we looked at this.
Mm-hmm.
And I see somebody who's actually said they've done this activity before.
Yeah, I use a lot of the geometry activities on the Nspire with my teacher candidates because we talk about the benefits of using the technology versus using other tools. So I really get on that practice about using appropriate tools strategically.
Well, so this is a particular focus at least with my teacher candidates as well. Is, it's been 3 or 4, maybe sometimes 5 years since they've had a geometry course, and so while we have a preparation course that's content focused on geometry, how to use the technology in an effective manner with students is something that they obviously, in a lot of their cases, didn't actually experience themselves as in the high school classroom. So there's a lot of things that they themselves figure out from going through these, and this idea of descaffolding really sort of in some instances, will really turn on light bulbs that they otherwise would not have done if it was still in the step-by-step manner.
Mm-hmm.
So we have a couple of comments here. From experience, I think only asking for the 2 angles we matched on purpose in number 2 and 3 helps them connect the third one that wasn't like supposed to match. It just ended up happening. Okay. And then having to do the chore of writing all 3 angles where they're same over and over again causes them to feel like it's just always the same. So, I mean, that's exactly the feel that I have when I initially looked at this lesson. Was they're told to drag the points, make certain angles equal to other angles, and so it does remove some of the thinking and the critical thinking.
And since Jessica's used this before, she should have a good sense of, what's too much for students, right? What could be removed and still get to the point.
So we'll give another minute here, see if anyone comes up with some additional ideas, and then we'll share our example. And I think you mentioned earlier, while some folks were thinking, a number of the technology lessons on the activities exchange, when they were written, were when teachers were adopting new technology or trying to integrate technologically driven lessons with either the 84s or the Inspires. Is a lot of them were written to try to remove that technology roadblock that might be for when students are using things for the first time or teachers are using them for the first time. And so keeping that in mind too, which is if our students are used to using the technology, then a lot of the scaffolding that are in some of these lessons are very easy to strip out because you don't need to do those step-by-step instructions with students all the time.
Mm-hmm.
All right, so we're going to jump forward here, and we're going to look at an adaptation, and I'm actually going to share that in a couple of fashions. So page 1.2 in this TI-Nspire activity, we see here on this page, and I've adjusted the M prime and N prime to get 60, 35, and 85 degree angles, and took a screenshot of that, and then I did the same thing on 1.3, and what you notice is the difference between the 2 pages in this in this lesson shows the ratios of the sides when you actually have M prime and N prime the same angle measurements as angles, or triangle PNM is the same as ABC. But what I did here on these 2 slides, and this was sort of a what I would expect to happen in the classroom is that I've created the 2 different possibilities in these 2 screenshots you're seeing. So the one on the top, you actually see that angle M is not congruent to angle A, but you still have a 60, 35, 85 triangle. Whereas in the lower one, you actually see angle M congruent to angle A, which is sort of what the instructions are in here. So students are going to just look to match up the numbers like I did in 1.2, but it's not actually the corresponding angles that the instructions give. So stripping away some of those make angle M congruent to angle A is going to allow students that opportunity to realize there's multiple cases. And so I didn't really revise the questions too much, with the exception of giving a mathematical argument for your conclusion there with number 2, because in 1A and 1B, they're going to go through that process of realizing that, some students are going to adjust M prime and M prime and get the first case that you see on the top, and some are going to do the one on the bottom on page 1.2. They're not going to see those constant ratios. And then you can kind of address those with some discussion and some purposeful questions, and you're going to be able to make connections between the 2 different representations that you can actually create 60, 35, 85 degree triangles on page 1.2. The strategy here for, and again, they're renumbered, but removing when you go to page 1.3, still seeing the significance about what happens when you do have the corresponding triangle, but this page will actually also give you the incorrect ratio if you create the triangle that you see on the top here on the lower page, and you'll get a ratio that's not the actual ratio. So it is a caution that needs to be dealt with before you get to 1.3, which is why the page 1.2 questions have been descaffolded to what I put here. The other part is that I thought part C, in that when Frank concludes that the two triangles are similar, is the reasoning correct? Explain why or why not. I felt like there was a little too much scripting in that one particular question, but it still was going to hit at making that reasoning of whether these triangles are similar or not, and using that angle side similarity property. So those are the two, taking those 2 pages, looking at what is going to happen when students work with those 2 dynamic pages, and still wanting to come to those conclusions that we want to see here. But then I don't want to lose the rich question that's at the end of this, but also even not lose the what are we going to do with this constant ratio. So one of those last questions was, use the scale factor or the ratio to be, I'm not saying scale factor, the ratio of the similar triangles. And so I didn't remove all of that. I still kept that in there so that we can see that they can take that ratio and use it appropriately, whether it's the smaller triangle or the larger triangle, and actually apply using that. So that part is still in there. We want to make sure that they can do that particular computation and skill. But then the question you did not see was sort of the culminating question that, and maybe Jessica can say whether that sort of fits in a traditional period classroom, whether that students actually get to spend a lot of time with this particular question and dealing with the image that is given and making sense of that image and applying what they've learned throughout this lesson with that question number 5, which was, I think, question number 8 in the original lesson that's on the website. So are there any particular comments maybe that folks would want to put in the text chat, or anything that you would want to add to this, Dan?
Yeah, I think when we think about those original criteria, right, we raised the cognitive demand because you took away some of that step-by-step, but you also added in a lot about giving students the opportunity to communicate about mathematics with the question about explaining, do we think that reasoning is correct, why or why not, give the mathematical argument for your conclusion. So you've included a lot of that piece as well. So you got kind of 2 criteria in there to get closer. And I don't think I mentioned this earlier, but one thing the study did say was these are the 4 criteria. Not every task is going to have all 4 criteria. Some may be not in it at all. Some may be less emphasized than others, but we want to try and get as much of that as possible.
Yeah, so some tasks may not fit all 4 of those, and it may be that, when we've done some of those example tasks that you and I worked on before, that, a number of participants sort of saw, well, it has 2 of them, and some of the other ones have 3. Does that make one task better than the other? And it may not be that all of those 4 characteristics are going to be embedded in every task. There's still good tasks that may only have 2 or 3 of those.
Mm-hmm. So just wondering if anybody has any comments about what descaffolding means. We had this 84 and Nspire example to just encourage you to take a look and see if we can remove some of that step-by-step and not give away so much of the mathematics to students. And we're using existing activities from both the Activity Exchange and the Math-Nspire site. So there's lots of opportunity out there to take a look at something that has an objective that meets your lesson objectives that you're working with, but then also take a critical eye to it and say, is the way that it's written, is that what works for me and my students? Or can I raise the cognitive demand by descaffolding some of it, or maybe adding in some different explanation pieces to it? All the activities are available in Word doc form, so you can edit away, right?
Which is exactly what I did with that. You can add things, delete things, whatever you feel is most appropriate to reach the mathematical goals that you have for your students. And again, some of the ones, leaving some of the technological steps in there sometimes are going to be appropriate. And it's not always going to be that a lesson needs to be de-scaffolded. But as far as trying to improve the experiences of our students from sort of what that adding it up or measuring up study concluded is that students aren't getting enough of these kinds of opportunities, and it's a relatively rare experience from what their data showed to be engaged in a little bit more tasks that have a little more cognitive demand and maybe a little less procedural and step-by-step oriented. So with the remaining time, we have one more strategy that we would like to present. And this is the strategy 3 that Dan mentioned earlier about turning procedures into problems. And so we sometimes have maybe an overemphasis on procedures, but that doesn't mean that procedures are not important or that skills are not necessarily something we want to cut out. But we do know from that particular study that is the very large majority of what we have students doing in classrooms. And so many of the current resources that educators have out there are worksheets, and a lot of them have rich practice problems and procedure type problems on them. But rather than saying we're just going to scrap our whole inventory, we're going to look for ways, and we're going to just kind of present this for you, is that how do you take this same practice or skill sheet here and actually insert something that's going to have students analyze and look through and make sense of what it is they actually did. And so given our time here, we're going to kind of just give a quick presentation here of what an example of this might look like. So we've done this with a factoring worksheet where we kind of look for some different patterns within a factoring worksheet. And this one is obviously dealing with the distance formula and distance of segments in between 2 points. And so the strategy here where we're talking about turning procedures into problems is nothing more than, so while we would still have our students do 1 through 12, or maybe we only have them do 1 through 4 and 7 through 10, and maybe we take a few of the practice problems away, but we ask them something additionally, which is to sort problems 1 through 6 from shortest to longest and justify that. And then with 7 through 12, find one segment that is longer and one segment that is shorter, and realize that there is a longest and there is a shortest, but it doesn't necessarily just ask for what is the longest and shortest. Students would be able to maybe look at those points and say, I can kind of visualize where they're at on the grid, and I realize that this one is relatively, these are 2 points far apart. That's my longer one. But they've given some mathematical reasoning to why they're saying that that's a longer one, and then they might look at one that, oh, these two lie in the same quadrant, so I think those are really close together, and that's my justification for a shorter one, and not just the computation part where they're going to get the distance, but they actually might be able to do this by making connections between where they see those points lying on the coordinate grid and making those connections to the procedures that they've actually just completed. So given our time here for tonight, that was one that we didn't give you a lot of time to think about, but taking a worksheet where we have students working on skills, the strategy here is to insert something where they have to look for patterns across the skill problems or the practice problems, or make sense of what they've done with those particular practice problems.
Mm-hmm. And we got a good response from James, who's saying, could students estimate? So I could imagine, like your point about the 1 through 6 is, before we calculate anything, can we predict as a class which one is going to be the shortest and which one is going to be the longest? Maybe write that out, and then row 1, you calculate problem number 1, row 2, you calculate problem number 2, etc., and then let's see how we did, right? So we're connecting that visual representation, our estimation skills, as well as being able to practice that procedure all at the same time.
Yeah, I agree. So like even the directions at the top, find the distance between each pair of points, those directions could be removed and present these, find the shortest to longest between 1 through 6, and you could do that in a lot of different ways. You could ask students to first make estimations of them and which ones they think would be the longest, and then actually go through that process of figuring out or justifying whether they were correct or not in their initial estimations. Yeah, good suggestion.
Yeah, so I think one of the things we're trying to encourage you here is to focus on um, the procedural and the conceptual. So rather than just having students go through these problems to do the practice with a purpose, um, with a bigger question in mind, so students still get that skill practice time in, but there's a bigger question that they're trying to answer because that'll help them look for some patterns, look for some structure. I look at questions 7 and 9, and they both have the same coordinate, the same for that second one. So I'm kind of like, I wonder if I could figure out which one's longer and which one's shorter without having to do a calculation, just by maybe picturing it or imagining which direction the segment may go. Does that help me? Because right, that visual image will certainly be a nice connection to this, the square root of, et cetera, et cetera, et cetera.
Exactly. And Jessica made a comment in there about, having students just being able to articulate why they picked. So that goes back to one of those characteristics where students have choice.
Mm-hmm.
They have an opportunity to sort of choose and then justify why they chose, as far as at least with the second one here with problem 7 through 12.
Yep. And so we had said earlier that it's not just adapting the tasks, it's how you implement them. And so teaching practice is also really important. So we want to wrap up in the last couple of minutes here just with some big ideas for you to think about and take with you.
Yeah, so if you haven't had a chance to take a look at the Catalyzing Change in High School Mathematics, Initiating Critical Conversations publication that came out last year at the annual conference for NCTM, so there's a lot of information in there, but the three that we sort of are highlighting here is that, like we did tonight, we chose 2 TI activities that could be modified and de-scaffolded. And so a lot of the talk or the critical conversations in this Catalyzing Change is dealing with how we can kind of improve what students experience in high school mathematics. But even a lot of what's in this book is also going to be, can also be done at the middle grades as well. And I will tell you that NCTM is getting ready to work on a middle school Catalyzing Change publication as well as one for the elementary grades. So this will not be a standalone publication. They're going to be following up with ones for the middle grades and the elementary grades. But according to that measuring up research that we saw, the ways in which students experience mathematics essentially needs to change to some extent for students to self-identify as doers of mathematics. We provide access to these 2 webinars in our series, sort of to get some steps towards maybe shifting some of our routines a little bit to where students have a chance to have some more cognitively demanding tasks, but not with reinventing every single lesson we do. Our time is very limited as far as what we have time to create or what we have time to modify. So while we only covered a couple of the strategies for increasing the cognitive demand of the tasks that we would want students to be engaged in, that success really depends on how we have our classroom set up and some of the classroom norms that both our students and ourselves as teachers are working towards. So we look at Horn's publication from 2012, Strength in Numbers and Collaborative Learning in Secondary Mathematics. So this is a really good list of items. And we're going to give you an opportunity here in the text chat if you have some additional ones that you'd like to share with everyone else who's on here tonight. And the ones that we have here are really about, these are being sensitive to students to be able to feel comfortable to engage in mathematical discussions so they can feel that they're improving their mindsets in the classroom. But also rather than not looking at students with necessarily a deficit mindset. And so Horn actually helps us make that shift to look at some of these terminologies when we're trying to implement some of these maybe more cognitively challenging tasks in the classrooms. So does anybody have any other ones they might want to add to this? So if you do, go ahead and put those on the text chat. I want to keep tell me what to write. Implementation of instruction has helped me, and this is my first webinar. I've learned a lot. Okay, thank you. And we're going to be cognizant of time here. We want to make sure that we end this sharp on an hour. So there's also a presentation that Gail Barreau gave at the California Math Conference, where it's called Instruction That Makes a Difference. And so she sort of put, while we want to have norms for students, we also need to have norms for ourselves. And so this is a list of what she presented, and a lot of them are based on some particular research studies that have been out there. And these are sort of some of those things, and this kind of aligns with some of the comments that we see in there that we need to, it also relies on us to be able to make some good comments to our students to be able to get them to engage in some of those more cognitively challenging tasks. And we're going to conclude tonight. Dan's going to kind of lead a very short reflection here. Go ahead, Dan.
Yeah, I think we're going to turn it back over to Mike, but as he kind of wraps it up for tonight, I want to give you a chance to kind of reflect on what you heard tonight, and if you could write a headline and put it in the chat from what you learned about implementing tasks that promote reasoning and problem solving. That'd be a good way to summarize your thinking, what we presented, and so we really appreciate you chatting with us tonight and learning some strategies to raise the cognitive demand, have your tasks that you're working with measure up in the classroom.
So I'm going to give the controls back to Mike here.
Thanks so much, guys. And as we do wrap things up tonight, if you do have any last-minute questions for Dan or Jeremy, please try to get those asked. I know they'll do their best to get those questions answered. One thing I do want to share on our website, again, education.ti.com, is in case you missed part 1, you can access that on our website under the Professional Development tab. At the bottom of that middle tab is Webinars, and then slide down to the online learning on the right-hand side. On-demand learning. And you'll find part 1 was just recorded and archived recently. I believe right now it's the 4th one down. So feel free to visit that. If you missed part 1 or if you want to see it again, all the documents are there as well as the recording, as well as the certificate as well. So please feel free to visit our website to learn more. We're excited that there's a lot of TQ summer workshops that are happening in and around the United States with lots of focuses, some on teaching strategies or focusing on the ACT or maybe STEM. Feel free to visit our website to learn a little more about workshops that may be coming to your area. Again, more information is available on our website, education.ti.com. And one lucky winner tonight is going to be winning a TCube Summer Workshop registration. And our lucky winner tonight is Charles Frederick. So Charles, congratulations. We'll be in touch over email in the next couple of days to give you a little more information. But we hope to see Charles as well as everyone else at a TCubed Summer Workshop. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link to the documents that were used tonight by Dan and Jeremy and myself. And if you miss these or maybe they're not working for you for some reason, just hang tight. You'll automatically get a follow-up email in a couple days. And in that follow-up email will be links to the recording, the certificate, and the documents as well. And if you want this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you need to get in touch with us for any reason, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. Thanks so much. So thanks to Dan and Jeremy for everything you guys shared tonight. Thanks for doing a part 2 follow-up to the part 1 a couple weeks ago. I really appreciate it.
Thank you. Appreciate everybody being with us tonight.
Thanks, everyone, for attending.
Thanks again, everyone. I echo Jeremy's sentiments. Thanks for attending. We hope to see you back online real soon. Have a great night.